Okay, so section 11.2. So we're going to be talking about today. What? There you go. Nice. So it's all about limits. And of course, limits, as you know, back when we talked about limits back in Calc 1, and you're like, oh, cool, here's this function. It's totally continuous. Hey, what's the limit there? I don't know, man. If this is f of x, and this is, x equals a, what is the limit as x approaches a of f of x? Well, if it's a continuous function, it's literally f of a, right? The only time we had issues was if we had a jump, if we had a hole, must very likely, or if we had an asymptote, also very likely, okay? So those are the ones, obviously, where there was a problem, okay, where there's an issue at a particular value, okay? Now, in this case, of course, this limit is going to infinity. This limit is also going to infinity. So some people would say the limit doesn't exist because infinity is not really bounded. Other people would say, no, it's infinity. That's great. This one here, look, this is, let's say this y value is approaching 5, this y value is approaching 5, but just right when it gets there, it doesn't exist. The actual value doesn't exist, but remember, the limit does exist. Now, recall when we did this, we had to approach it from both sides. Remember, for the limit to exist, the limit as x approaches a from the left of f of x must equal the limit as x approaches a from the right. And if they do, then the limit exists, right? So in other words, so this one exists. So if you tell me it exists, then I know those two are equal. If you show me that they're equal, then I can tell you that limit exists. Okay? Now we're going to do some easy ones here, and we're going to get crazy. And at times you're going to be like, oh, that one can't work because, and I'll be like, you're right, sure enough. And so on. So it's going to be pretty, some of these are going to be easier than others. Okay, some of them you're like, what? That's going to be hard. No, just calm down. It's going to be all right. So the limit is x and y approach the point 1 comma negative 1 of e to the negative x net y. There you go. Cosine x plus y. Oh, that's great. Now, first thing to come to mind is this. Is there anything that you cannot take the cosine of? Nope. Last I checked, you can take the cosine of any number. You will get somewhere between negative 1 and positive 1, but you will always, it's capable of doing it. And is there anything that I can't raise e to? Well, besides infinity, no. No, there's not. Okay? And it even, whatever. So I'm not asking about those. I'm asking about negative 1 and 1. So watch what happens here. If I put in these points, in other words, this, what we know then, this is continuous function. So the limit of a continuous function is you just plug in the numbers. So that's going to be e to the 1 times, what's the cosine of 0? Which is 1. So e to the 1th, or 2.718, yada, 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 right? Yay, the crowd goes wild. However, as you might suspect, none of them are going to be that easy. And you're absolutely right. And so, that's just kind of how it's going to be. We're going to do one like this guy here, perhaps. The limit as x and y approach. Actually, I'm going to leave that alone for a minute. I'll have you tell me what you think it's going to be approaching. Jay, we can't talk back to you. I know. I'm just saying that. Listen, 0, 0 is the only place where this function is not defined. Am I right? If x and y were both 0, this thing would go, we'd have a problem. Okay? And that's clearly true. That would make the denominator equal 0. Couldn't there be something where they'd add to 0? No, because they're both positive. And when you square it, it's going to be positive. And so that's a problem, obviously. So 0, 0 is the one that's going to be interesting. Again, if you was 5 and 5, you just dump in 5 for everywhere and just go nuts. It's like, so what on earth do we do here, Jay? How are we going to figure this out? Well, This one's actually sort of interesting, sort of not, whatever. Can we, remember, because back in the day, sometimes you would look at, if you looked at this problem here, you throw 0, 0, and you get 0 over 0. You're like, ooh, L'Hopital. Well, it's kind of hard to do old L'Hopital in this situation. But yeah, we had other ways of making them talk, you might recall. So let's do this. Let's just punch in old parentheses, x squared. Sine x or sine y? I don't remember. I don't listen to myself. Sine, oh, that's right. Sine squared y. What? Now look at that now. That's just freaking cool, man. Hey, all right. So right there at 0, 0, clearly that function does not exist, but it sure looks like everything is approaching. Gosh, it sure looks like it's approaching 0, 0, doesn't it? Weird. How cool is that? It looks kind of like, oh, now is that enough to prove it? Of course not. Silly knucklehead. Of course not. Now, hold up. So, a couple things you can do. Okay, a couple tricks you can try. Okay, and some of these guys, they're still going to, oopsie daisy, you're still going to get ugly answers. You're still going to have to kind of do some guessing and checking on some of them. Okay, some of them you can actually straight up prove. This is one of them, I think, pretty close you can prove. But other ones, not so much. Now, recall, when we were in 2 dimensions, you had to approach x equals a. You had to approach it from both sides. But if you're approaching a point, that is the 0, 0 point in our case, well, you're like, well, you have to approach it from, like, all 4 sides, I guess, kind of thing, right? And you're like, well, yeah, I guess. Here's a problem with that, though, okay? If you let y equal 0, right, that is, you're coming down the x-axis, right? Sometimes, not always though, but sometimes what you end up with is you end up with some real significant issues. This one isn't one of them. This one's actually not too bad. If you let y equal 0, these pieces here cancel out, and you're left with x squared over x squared, right? Which 2x squared, which reduces to 1/2. And you're like, ooh, say that's interesting. What is the limit of that as x approaches 0? Well, it looks like it should be 1/2, Jay. Is that going to work? Is that going to be right? No, we'll see. We'll see, friend. We'll see. And then other people are like, well, now wait a minute. You thought maybe it'd be 0. I thought it looked like it was not infinity, or didn't, you know what I mean? It looked like it's going to go to somewhere. It's not a ginormous asymptote, I guess is what I'm trying to say. And you could let's let x equal 0. Let's come down the y-axis. All right, cool. So sine squared of y over y squared. If a guy were to graph that, and I think that's actually kind of a fun one. Oopsie daisy. Come in here and go, let's just graph this as x squared. Divide by sine x squared. Uh-oh. Oh, well, that's a 22nd power, you jackass. Maybe you do it right. Look what they approach, friends. Hey, they also approach. They look like they approach what? 1/2. They look like well, actually not 1/2. It looks like they approach 1. Well, that's kind of weird. That's odd, I feel like. So it seems weird. Now, there's a couple other things you can do. You can say things like this. You could say, well, we could also, there's no reason we have to come down the 2 axes. What if we approached it along the line y equals x? And along the line y equals negative x? Then what would happen? It's a great question. Let's let x equal y. Or let's let y equal x, I guess, sure. So it's going to x squared plus sine squared x divide by, that's going to be 3x squared in the bottom there. And you're like, oh, that's exciting. What's that going to do for us? Well, I don't know. So again, different things are going to happen here. It's like, this is really hard. It's confusing because of this stupid sign. Okay. Well, what am I going to do instead? Allow me to demonstrate. This is my preferred method, actually. I rather enjoy this. I look for an excuse to pull out my Excel. Gosh help me, I love Excel. Now, this, to me, is a nice way of going about it. Now, it's not, if you were to talk to some people, they get all weirded out because, well, now, Jay, you really need to prove it. Yeah, sometimes you can, sometimes you can't, to be honest with you, for being perfectly, truthfully honest. Sometimes you can prove it, sometimes you can't really prove it. I'm going to start at 2. Actually, I'm not. I'm going to start at 1. I lied. I'm going to go back to 1. And I'm going to say equals this fella plus 0.1. And actually, I want to go -1 here. Sorry about that. So what I'm going to do is I'm going to drag this guy along until I get to +1. And in the meantime, I will have gone past 0. You see that? Now you see that e to the -16 routine? That guy is 0. Okay? Why does the computer write that way? I have no idea, to be honest with you. Well, I mean, I do and I don't. I mean, there's a reason for it. Sometimes in a calculated value. In this situation, no. Oh, fart. Just a minute. In this situation, I don't believe there's any use for why that happens. But in a situation where you're doing calculations, it makes sense. In this one, not so much. Now, our formula was, correct me if I'm wrong, it was equals. And I'm going to take this guy here. I'm going to treat these as my x's. So I'm going to go x squared. Now, be careful when you do this. You want to make sure that you hit your function F4 button. And I want the $sign to be in front of the 1. That's going to hold us in that top row. Plus, parentheses, sign of y. And I want to hit the function key until I get the $sign in front of the A. That's going to hold it in the first column. Squared. Divide by 2 times x, again, squared, plus y, again, squared, like so. What did I mess up? Yes, that's fine, I think. So, what I normally do is drag it down and then over. And then I click on one of these guys and see if I'm calling everybody correctly. If I've done it correctly, oh, don't go to sleep. If I've done it correctly, I will always be highlighting this one and that one. If I did it wrong, what would end up happening, let's say this guy here. Oh, just a minute. Oh, fart. Just don't, no, okay, just a minute. Let's say I messed up on this first one here. Are you with me? Now when I drag it down, and then I drag it across, and then I check this guy here, notice how it's this guy I'm calling on. That should never happen. It should always stay on this X for this column, this Y for this row. So again, to do that, make sure you get your $signs in the appropriate locations. Okay? So now that I know I've done it correctly, I'm going to repaste it here. And then I'm going to drag it across. Now, the point in question, of course, is 0, 0. Well, 0, 0 is right in here somewhere, friends. You see this? And so as we're coming in, you're like, oh, yeah, right on. Here we go. Oh, yeah, wait. What's going on here? So if I'm coming down this direction, these guys, they sure look like they're approaching 1, but then they kind of drop into, oh, it's here right here at 1/3. So at 0, 0, it's giving us a value of 1/3. Now, the reason it's giving me a value of 1/3 is because why? Because this isn't exactly 0. Are you with me? If this was 0, and this were 0, it would say divide by 0 error. Okay? But notice coming from this direction, it looks like it's going to 0, but then it's not. And these guys looks like it's going to 1/3. Yeah. And these guys coming down this direction looks like it's going to 1. And you're like, I don't understand. Can you hone in closer, Jay? Love to. Let's get a little bit smaller here. Let's go -0.2. And let's click on this fella and go by 0.01. And let's paste that across like so. Oh, I haven't got close enough to 0 yet. Oh, darn it. Just a minute. Let's do that different. Let's do 0.05. Let's do that. That's more better, maybe. I'm just trying to make sure that I have 0 accounted for without going crazy here. And so what can happen sometimes when you're playing this game is you're like, wow, you're doing approximates, but it depends on how close you get. That's right, it does. So in this situation, if you come in here, you can keep playing these games and get closer and closer and closer. Now, where is our 0, 0? There's our 0. And there's our 0, yes. And again, as I'm getting closer and closer and closer, these still look like they're going to 1 this direction. It still looks like they're going to 0 coming from this direction. And here it kind of looks like they're going to 1/3. And you're like, what the Sam Hill's going on? Can you get me in a little closer, Jay? I think so. So let's see what happens here. So let's actually zoom in a little tighter. And I want you to see what you see. And maybe this will help us. Now, is there a better way? In some of them, yes. But this one with the sign is really killing us here. Because no matter what I do, oh, fart. No matter what I do, it gets a little screwy. Because of that sign ratio. Oh, for the love of Pete. Now zoom in on it. Nope, don't do that. Stop it. I'm getting dizzy. Stop it. Oh, that's too much. Anyway, what I was hoping that you'd see is this. This looks like it is gradual. It's really not gradual. Are you with me? So coming down this way, it looks like it's approaching 1. And then all of a sudden, it just drops like a rock because it doesn't exist. Coming in from this direction, it looks like it's 0. Okay, but then all of a sudden it just disappears and it's not there. Are you with me? And so what I'm hoping that you see is they're approaching different things from different sides. So the answer is the limit does not exist. Okay, the limit does not exist for this number particular problem here. Okay. Now, again, was that really satisfactory? No, not really. Because again, if you do it this way, you're like, oh, clearly it's 1/3. Clearly it's 1/3. And then coming at it from the other point of view, you're like, oh, yeah, maybe it's 1/3. And it is. If you come at it from this direction and this direction, it is 1/3. If you come at it this direction, it was 0. This direction, it's 1. And that's exactly what we saw in the computer, or in Excel. Now, here's another example of one that's going to be a little nicer to fool with. And I can't guarantee it's going to work. But again, it will look nicer because of the way it's laid out. That stupid sign isn't in there messing everything up. So this one is going to be 6x cubed y. I will tell you right now, this is not my favorite section. It's just a little hard to see. And it's a little harder to sell people on, limits from this standpoint in this section, in this class. If you're going to talk to me about setting up limits in Calc 1 and Calc 2 for integrals and derivatives and stuff, yes, I beat them to death. Why? Because what is a limit? What is a derivative? It's a limit. What's an integral? Hey, it's a limit. Well, isn't that what we're going to do in this class too? Well, yeah, but I don't think I have to sell you on that anymore. I think that's pretty clear. We've all known that. So now all we're doing is 2 different limits in the integrals and the derivatives. So it's not quite the same. Now here, obviously 0, 0 is a problem. Am I right? And by the way, you cannot let y equal 0. It can't happen anywhere. Okay? Because if you let y equal 0, and then you're like, well, let's see what happens as x goes to 0. Oh, wait, the top's already 0. Oh, that sucks. It's always 0. What if x is 0? Oh, well, then the whole thing is 0 because the top's 0. Oh, that blows. I can't do that. But here's an example of where you can let y equal x and y equal negative x in turn. So if you let y equal positive x, you'd get 6x to the 4th on top. On the bottom, you'd have 3x to the 4th, and that would reduce to 2. Nice. Well, what happens if y equals negative x? I don't know. Yes, I do. It's the same. So are you saying that the limit really ought to be 2? Boy, it sure looks like it. I wonder if that would be true in Excel. I don't know. Let's find out. I'm going to change this one to start at 0.5, I think. Yeah, that just kicks it over. It just makes me a little happier. It's a little more fancy. All right, whatever. So then here we go. I'm going to come in here and just change my formula. You with me? So my formula is equals, what did I say it was? 6x cubed. So 6 times x cubed times y just times y, right? Yep. Divide by parentheses 2x to the fourth plus y. Now be careful what I do. I forgot to lock that in. Are you with me? I need to lock that in front of the a. There you go. And then close your parentheses. Enter. Now I'm going to paste it down. And then paste it across. And again, before you get carried away, do come in here and click on one of these guys and go, oh, is it still dragging from the approach? It is. So that makes me happy. Here's a problem. It sure looks like, coming from this point of view and from this point of view and this point of view and this point of view, it looks like everybody's approaching too. Sure does. Is that true necessarily all the way around that guy? Now, before you answer, remember this is truly 0. And this guy is truly 0. And you're like, ooh, divide by 0. Oh, no. All right. And so as you're coming in, you're like, wow, this looks very strange. It looks very odd to me. It looks like, man, we've got some weird stuff going on. And in fact, why is this one negative 2? That one's creeping me out. This is y equals 2. Why is that negative? Did I just not do math correctly? X squared plus y. Oh. Yep, it would be negative 2 on this one. And why is that? Because it's not 6x. It's going to be, if you let y equal negative x, then you're going to have a negative right here. That's going to be negative. That's going to be negative 2. Okay? The fact that they're different, what does that lead me to believe? It's going to lead me to believe that this guy does not have a limit that exists. Phew, glad I caught myself on that guy. Now, what you can do on this guy is just restore this, and I'm going to zoom back out, I think. Somehow, I don't know how I got that quite tightly zoomed in. Oops, there we go. Cool. Give me back my 100%er, will you? Thanks. I'm going to type in this new one here. And it was 3x to the third times y divided by parentheses 2x to the fourth plus y to the fourth. I think I see your I think I see what I'm doing wrong there in that regard. I guess it should have been 6x, I believe. That makes me happier, I think. Cool. What? Look at that Dorita chip looking thing again. Again, approaching it from this standpoint, where's it going to be? Way up here at positive 2. Approaching it from this side, it's going to be there at negative 2. Where do they agree? They never agree. The limit does not exist. Okay? Now, again, pay attention to that negative sign there. I kind of screwed that one up. No, I didn't kind of screw it up. I totally screwed it up. Here's another one that's kind of nice, I think. This one will bring you back to Algebra 2, probably. In your mind, you're like, oh, what a wonderful time that was. Mr. So-and-so, what a great fella, or lady maybe. I don't know who was your teacher. This one will bring you back to the good old days. Obviously, x and y cannot be 0 and 0, obviously. Wait, that sucker factors. You better believe it factors, pal. It's a difference of squares, Jay. I know. That's why I did it, man. Hey, those guys cancel off. That's right. And you're left with x squared minus y squared. You are. Now, hold up. If it can reduce to the point where this 0, 0 is no longer a problem, what does that tell me? It tells me that that was a whole. And that tells me that the limit does, in fact, exist. And what is the limit of x squared minus y squared if they're both 0? It's 0. Now, let's see if that's true in the old Excel machine here. Okay, now again, any one of these sometimes will work. Sometimes they do, sometimes they don't. You just have to pay attention to see if, this particular one's going to work for us or not. So there's x to the fourth. What is it? X to the fourth minus y to the fourth. Divide by x, no, see, I do that sometimes. I'll actually type in x, and I don't mean x. X oh no. What just happened? What just happened? Clearly they're going to be a problem, you see, when they're equal to one another, aren't they? Mm-hmm. And while they went, yeah, so when they're equal to one another, there's going to be a problem because you're subtracting, you're adding on the bottom. Did I do a minus? Oh, I did a minus on the bottom. That's my problem. Should have been a plus. Nice, there we go. Maybe it'll work this time, you big dope. There you go. So, as you're coming across, all roads lead to 0. Are you with me? Doesn't matter which direction I come from, all roads lead to 0 here. Every single one of them is headed towards 0. Every single one of them. What does that tell me? It tells me my limit is 0. That's nice. Again, if you were to go look at the graph on this one, fortunately, there's not a ton of problems on this particular assignment, so you don't have to fool with that. You don't have to go, this is so hard, there's so many of them, I'm not going to do that to you. I don't think it adds a whole lot to the material, this particular amount of limits. We assume that you know what you're doing with limits because you took Calc 1 and Calc 2. Hey, what do you know about that, friends? Look at that. It's a Pringles potato chip. Okay, by the way, that's a saddle point. That is literally the best saddle point that you could ever find. What's happening at 0, 0? It is a hole at 0, 0. But everything else is fine. No matter which direction you come, all roads lead to 0. Everything. Doesn't matter which way you approach it. Everything's headed to z is equal to 0. I think we do one more example of these, and then we call this one a day. All right. This one here, for instance. Oh, mercy. Should we do that one? Now I'm going to pause while I pick a good one. Okay, this one comes along then, and you're like, cool, all right, nice, not too bad. So this one here, I want you to just kind of think about this for a minute here, okay? No matter what, obviously x and y both can't be 0. But what's going to happen to this equation? If you're thinking about this right now, what's happening to this equation as you're approaching 0, right? So obviously, if you're approaching infinity, the denominator is going to be growing bigger and bigger and bigger, obviously with that y to the 8th business there. So just kind of keep that in the back of your head as we're going along here. But because we're approaching 0, okay, as we're getting closer and closer to 0, as our y is getting closer and closer to 0, that's getting to be a tiny number, and then same with the x squared down there, okay? When you square them and then add them together, right, they're getting smaller and smaller numbers. But the denominator is getting smaller, really small, okay? And so, you know, what's going to happen here? Are we just going to overshoot, undershoot? What's going to be happening? But interesting enough is that as we approach, let me put it this way, as x and y go to infinity, if we did it that way, obviously the denominator is getting huge in a big hurry because it's y to the 8th. Are you with me? It's getting big in a hurry because obviously that y to the 8th is doing a lot of the driving. Okay. As we're going closer and closer to 0, the x squared is doing most of the driving. Okay, because obviously if you start raising tiny numbers to big powers, they get even smaller and smaller and smaller. Okay. And so what's going to end up happening is that this guy is going to be doing most of the driving in the denominator. This piece here is basically going to go to 0. This piece here is going to stay a little bit bigger. You're going to add those two together. You're going to have this tiny number in the basement. All right, that's cool, whatever. All right. So then on top, you're going to be raising basically the same tiny numbers to the 5th power. Okay, well, what's going to end up happening is that it's going to be basically, when you do that, you're going to end up, when you divide this out, you're going to end up with a number that's awfully close to 0. Now, a nice way to show that on this one would be to say, let's let y equal x. Okay. Obviously, we cannot let x and y equal 0 because it'll be 0 coming down both axes, and that's not okay. So this is going to be x to the 5th over x to the 8th. Cool, I guess. That makes, sure, I guess, whatever. Now, what a person can do then, of course, is, well, could we factor that out a little bit? Yeah, kind of, yeah, sort of. So then you could say, well, things like, for instance, that's, x to the 3rd over 1 plus x to the 6th, I guess, right? And as this gets closer and closer and closer to 0, now at this juncture, could you let x go to 0? You can. And what are you going to be left with? You're going to be left with 0 over 1. Can you all see that? So now it's not a problem because there's still a 1 all by itself in the denominator. Okay. Likewise, you could say, let's let y equal negative x. Would it change anything? In this case, well, no, because the y is to the 4th power and y is to the 8th power. It'd be the exact same thing. So I went ahead and put it into Excel, and you can see all roads lead to 0. And then, of course, over here, I also went ahead and graphed it. Now, again, the graph is not obvious, like, oh, totally, it's 0, Jay, all right. But it looks like that, yeah, I could probably buy that. Notice that it's not the extreme drop-off that we saw on the other ones. Okay? You can kind of see that in there. Again, this is not enough to prove it to you, but it's enough to kind of point you maybe sometimes in the right direction if you think you may have missed something. So the limit is equal to 0 this time. Okay?